Simultaneous linear equations. Example 1. Problem. Solve the following simultaneous linear equations. 2x plus 3y plus 4z equals 8. 3x plus 2y plus z equals 12. Y plus 3z equals -1. Solution. Because the equation 3 does not include x, this variable should be the best one to be eliminated from the above simultaneous linear equations. To do this, multiply both sides of equation 1 by 3, and both sides of equation 2 by 2, then subtract equation 2 from equation 1 side by side. The following equation is obtained. 3 times the left-hand side of equation 1 minus 2 times the left-hand side of equation 2 equals 3 times, open bracket, 2x plus 3y plus 4z, close bracket, minus 2 times, open bracket, 3x plus 2y plus z, close bracket, equals 5y plus 10z, equals 3 times 8 minus 2 times 12, equals 0. So, y equals -2z. By substituting y in the equation 3 by -2z, the following result is obtained. Equation 3 is equivalent to -2z plus 3z equals -1, which is equivalent to z equals -1. So, y equals -2z equals 2. Now, substitute y and z in equation 1 by 2 and -1 respectively. The root of x is found to be as follows. 6x plus 18 minus 12 equals 24, which is equivalent to 6x plus 6 equals 24, which is equivalent to 6x equals 18, which is equivalent to x equals 3. Example 2. Problem. Solve the following simultaneous linear equations. 7x minus 2y plus z equals 14. -3x plus 3y minus 2z equals 0. X minus 4y minus 2z equals -23. Solution. It is obvious that z is the variable that is easily eliminated from the given simultaneous linear equations. By multiplying both sides of equation 1 by 2, then adding equation 1 to equation 2 side by side, the following equation is obtained. 2 times the left-hand side of equation 1, plus the left-hand side of equation 2, equals 2 times 14 plus 0 times 2, which is equivalent to 2 times, open bracket, 7x minus 2y plus z, close bracket, plus, open bracket, -3x plus 3y minus 2z, close bracket, equals 28, which is equivalent to 11x minus y, equals 28. Let the above equation be equation 5. Subtract equation 3 from equation 2 side by side, the following equation is obtained. The left-hand side of equation 2, minus, the left-hand side of equation 3, equals 23, which is equivalent to, open bracket, -3x plus 3y minus 2z, close bracket, minus, open bracket, x minus 4y minus 2z, close bracket, equals 23, which is equivalent to -4x plus 7y, equals 23. Let the above equation be equation 6. By combining both equation 5 and equation 6, the following simultaneous linear equation is obtained. 11x minus y equals 28, -4x plus 7y equals 23. By multiplying both sides of equation 5 by 7, then adding equation 5 to equation 6 side by side, the following equation is obtained. 7 times, open bracket, 11x minus y, close bracket, plus, open bracket, -4x plus 7y, close bracket, equals 7 times 28 plus 23, which is equivalent to 73x, equals 219, which is equivalent to x equals 3. By substituting x in equation 5 by 3, the root y is found to be as follows. Y equals to 11x minus 28, equals 11 times 3 minus 28, equals 5. By substituting x and y in equation 1 by 3 and 5 respectively, the root z is found to be as follows. Z equals 14 minus 7y, equals 14 minus 7 times 3 plus 2 times 5, equals 3. Example 3. Problem. Solve the following simultaneous linear equations. Negative 2x minus y plus 5z equals 2. For x minus 4y plus 3z equals negative 1. 5x minus y minus z equals negative 15. Solution. It is obvious that y is the variable that is easily eliminated from the given simultaneous linear equations. By multiplying both sides of equation 1 by 4, then subtracting equation 2 from equation 1 side by side, the following equation is obtained. 4 times the left-hand side of equation 1 minus the left-hand side of equation 2 equals 4 times 2 minus negative 1 equals 9, which is equivalent to 4 times open bracket negative 2x minus y plus 5z close bracket minus open bracket for x minus 4y plus 3z close bracket equals 9, which is equivalent to negative 12x plus 17z equals 9. Let the above equation be equation 5. By multiplying both sides of equation 3 by 4, then subtracting equation 2 from equation 3, the following equation is obtained. 4 times the left-hand side of equation 3 minus the left-hand side of equation 2 equals 4 times negative 15 minus negative 1 equals negative 59, which is equivalent to 4 times open bracket 5x minus y minus z close bracket minus open bracket for x minus 4y plus 3z close bracket equals negative 59, which is equivalent to 16x minus 7z equals negative 59. Let the above equation be equation 6. By combining equation 5 and equation 6, the following simultaneous linear equations are obtained. Negative 12x plus 17z equals 9. 16x minus 7z equals negative 59. By multiplying both sides of equation 5 by 4 and multiplying both sides of equation 6 by 3, the following simultaneous linear equations are obtained. Negative 48x plus 68z equals 36. 48x minus 21z equals negative 177. By adding equation 5 and equation 6 side by side, the following is obtained. 47z equals negative 141, which is equivalent to z equals negative 3. By substituting z in equation 5 by negative 3, the following is obtained. Negative 48x plus 68 times negative 3 equals 36, which is equivalent to x equals negative 5. By substituting x and z in equation 1 by negative 5 and negative 3 respectively, the following is obtained. Y equals negative 2x plus 5z minus 2 equals negative 7. Example 4. Problem. Solve the following simultaneous linear equations. 10x plus 3y plus 3z equals 7. Negative 4x minus 2y plus 3z equals 13. 7x minus 5y minus z equals 24. Solution. It is obvious that z is the variable that is easily eliminated from the given simultaneous linear equations. By multiplying both sides of equation 3 by 3, then adding equation 3 to equation 3 side by side, the following is obtained. 3 times the left-hand side of equation 3 plus the left-hand side of equation 1 equals 3 times 24 plus 7 equals 79, which is equivalent to 3 times open bracket 7x minus 5y minus z close bracket plus open bracket 10x plus 3y plus 3z close bracket equals 79, which is equivalent to 33x minus 12y equals 79. Let the above equation be equation 5. By multiplying both sides of equation 3 by 3, then adding equation 2 to equation 3 side by side, the following is obtained. 3 times the left-hand side of equation 3 plus the left-hand side of equation 2 equals 3 times 24 plus 13 equals 85, which is equivalent to 3 times open bracket 7x minus 5y minus z close bracket plus, open bracket, negative 4x minus 2y plus 3z, close bracket, equals 85, which is equivalent to 17x minus 17y, equals 85, which is equivalent to x minus y, equals 5. Let the above equation be equation 6. By combining equation 5 and equation 6, the following simultaneous linear equations are obtained. 31x minus 12y equals 79. X minus y equals 5. By multiplying both sides of equation 6 by 31, the following simultaneous linear equations are obtained. By subtracting equation 5 from equation 6 side by side, the following is obtained. Negative 31y plus 12y equals 155 minus 79, which is equivalent to negative 19y equals 76, which is equivalent to y equals negative 4. By substituting y in equation 6 by negative 4, the root x is calculated as follows. 31x minus negative 4 times 31 equals 155, which is equivalent to x equals 1. By substituting x and y in equation 3 by 1 and negative 4 respectively, the root z is calculated as follows. 7 minus 5 times negative 4 minus z equals 24, which is equivalent to z equals 7 plus 20 minus 24 equals 3. Example 5. Problem. Solve the following simultaneous linear equations. 2x plus 15y plus 6z equals 47. Negative 3x minus 4y plus z equals negative 18. 6x minus 2y minus 7z equals 6. Solution. It is obvious that x is the variable that is easily eliminated from the given simultaneous linear equations. By multiplying both sides of equation 1 by 3, then subtracting equation 3 from equation 1, the following equation is obtained. 3 times the left-hand side of equation 1 minus the left-hand side of equation 3 equals 3 times 47 minus 6 equals 135, which is equivalent to 3 times, open bracket, 2x plus 15y plus 6z, close bracket, minus, open bracket, 6x minus 2y minus 7z, close bracket, equals 135, which is equivalent to 47y plus 25z equals 135. Let the above equation be equation 5. By multiplying both sides of equation 2 by 2, then adding equation 3 to equation 2 side by side, the following equation is obtained. 2 times the left-hand side of equation 2 plus the left-hand side of equation 3 equals 2 times negative 18 plus 6 equals negative 30, which is equivalent to 2 times, open bracket, negative 3x minus 4y plus z, close bracket, plus, open bracket, 6x minus 2y minus 7z, close bracket, equals negative 30, which is equivalent to negative 10y minus 5z equals negative 30, which is equivalent to 2y plus z equals 6, which is equivalent to z equals 6 minus 2y. Let the above equation be equation 6. By combining both equation 5 and equation 6, the following simultaneous linear equations are obtained. 47y plus 25z equals 135. Z equals 6 minus 2y. By substituting z in equation 5 by 6 minus 2y, the root y is calculated as follows. 47y plus 25z equals 47y plus 25 times, open bracket, 6 minus 2y, close bracket, equals 47y plus 150 minus 50y, equals 150 minus 3y, equals 135, which is equivalent to y equals 5. By substituting y in equation 6 by 5, the root z is calculated as follows. Z equals 6 minus 2y equals 6 minus 10 equals negative 4. By substituting y and z in equation 1 by 5 and negative 4 respectively, the root x is calculated as follows. 2x plus 15y plus 6z equals 2x plus 15 times 5, plus 6 times negative 4 equals 2x plus 51 equals 47, which is equivalent to x equals negative 2.